People back to order. We're going to get started with the first session of presentations today. I'd like to introduce the session chair, Simon Hodson. If you were at the cocktail last night on the boat, you know that he's the executive director of CODATA. He's been in that position for about a decade. He's done some pretty interesting things in that time. He was in the OECD Expert Committee on FAIR, right? They wrote a document called Turning FAIR into Reality, and you should Google that and check it out. It's, I think, foundational in the way that FAIR is playing out in Europe. And then, Simon, you were one of the editors of the UNESCO recommendations on open science, right?
So I was the vice chair of the expert advisory group for that recommendation.
Okay.
Yeah. And so that group did a lot of the drafting, and then, of course, it went through the mill of national approvals, and we managed to save most of the text.
Okay. So Simon's mostly a data policy guy, I guess, but understands the importance of metadata and technology and other aspects of that picture that are probably nearer and dear to some of our hearts. And I guess the last thing I would say about Simon is that he's great to work for and with. So, over to you, Simon.
Thank you very much, Arafan. So I don't need to introduce myself anymore. So welcome to session 4. The theme of this session is really fair. And I think all the speakers are going to talk about how we implement the FAIR principles, or how the FAIR principles can be a guide to what we do in official statistics or other forms of data. So whether that's FAIR plus linked open data, that's the theme and the thread which runs through the 4 talks. I'm going to ask each speaker to talk in turn, and then we'll have questions and discussion at the end. And I think that's an easier way to manage the time. And I'll introduce each speaker, not now in series, but as they step up. So perhaps the first speaker could go to the rostrum. Olav ten Bosch is a project manager at Statistics Netherlands with a background in theoretical computer science and a PhD in electrical engineering. He works in data-intense and international standardization projects on statistical open source software, metadata standards, data visualization, data validation, web scraping, and applied subjects such as energy, air quality, and open data. Olav has been a member of various international standardization groups, including SDMX, ESS standards, and a work package lead on new use cases in the European Web Intelligence Network project. And Olav will speak to us about FAIR to be fair, what is missing in official statistics. Olav, the floor is yours. You have 15 minutes.
Thank you, Simon. Yes, a long introduction. So with my colleagues, Edwin de Jonge and Henk Laloli, we made up this title, and it was meant to be a bit of provoking. To be fair, what's missing in official statistics? So we're looking at the official statistics, our job, making good statistics from a fair viewpoint, and we're not always happy, let's say. I'm talking about the official statistics landscape. What is that? That's kind of all the statistics that we produce with all the organizations making official statistics. I take a software perspective on this landscape. I talk a little bit about linked data, really a little bit because of time, and only one slide about the FAIR digital objects, and you probably don't know what's that, but it might be interesting. And so to start with, very simple. I'm from Statistics Netherlands. We have, as many statistical officers, we have a beautiful website designed by communication specialists from top to down, starting with a homepage with themes, and then you can go down to articles, news articles, thematic pages, visualizations. You click down, and you know the data scientist doesn't want it all. They want data. They want data and good metadata. This, in the end, if they find it, then they come into pre-selected tables, and in the end, in the statistical database. And this is pretty much the case for many statistical officers. Somehow we all have a dissemination system with statistical facts. In our case, we have it for a long time already. It's big because we never throw away our data. 2.4 billion statistical facts, active tables, being maintained by all the statisticians. It's publicly available. You can search, select, filter, download. It's not in SDMX, but we will go to SDMX. It has an API, it's OData, one of the few. And there's software around. So that's us. But zooming out to the official statistical landscape, then we are not the only one. And looking at my slides this morning, I realized that I should have put Insee on it, of course. I'm sorry. Completely mistaking what it was taking. Sorry, Frank. Next time I will. So, statistical officers like Denmark, Netherlands, Germany, and Italy all have sometimes similar systems, sometimes different systems. A lot of data, metadata, and high-level content. And we have the international organizations using the same data, or adding data, or improving data. And this all I call the official statistics landscape for this presentation. So on this landscape, I want to take a very different viewpoint, and the viewpoint is the software viewpoint. I'm also one of the authors of the so-called awesome list of official statistics software. What's that? So with all the statistical officers, we do kind of the same. We make statistics. And we do very complicated operations there. There's a lot of methodology involved. And methodologies implemented in R packages, Python, whatever, and open source software. I'm a great fan of open source software. And if you implement it once and use it in many offices, we are very efficient. So to memorize what's there already, we started this awesome list of official statistics software. It's a mouthful. You can find it on awesomeofficialstatistics.org or type it in Google. And actually, it's maintained by the community. Because if someone has something that thinks is interesting for someone else, give me a mail or send something. On the right, you see a picture of the GSBPM, the Generic Statistical Business Process Model. That's something we use in official statistics to design our processes, let's say, and this visualization says where the official, the open source software is around. So that's a sidestep. One of the categories on this list is access to official statistics, and it happens to be the largest category. So this is how it looks, screenshots of the list. You have a badge, whatever, where it's on GitHub, and if you click on it, you are directed directly to the software. So this access to official statistics has over 30 software packages given access to more than 60 data providers on the landscape. Mostly R packages. And these are generated by the data science community around us. So knowing this all on this list, I could do a kind of analysis of what's in this landscape on the software around us and create a matrix based on the documentation. It was a lot of work to read all the documentation, by the way, and created a matrix of all the packages on the list, 38, the data providers, 60 data providers, and the standards being used. And that's quite interesting. Of course, the well-known standards, but not mentioned in this conference yet. JSON-Stat, OData, PCXs, SDMX, and other are visible in this matrix. Well, you see it on a high level, you can click on it. It's, if I maintain the list, and it's being updated as well. And from a high-level viewpoint, you can see that the world in this landscape is divided into, let's say, the ones that support JSON-Stat and PCXs, it's related, and SDMX, the yellow ones. It's almost a disjunct world. And there's only one, and that's us, that have chosen long ago for OData, which was a completely wrong choice if you see this landscape. So we're actually going to move to SDMX as well. I'm happy with that. So this is horizontally. But if you look vertically, then you have this like, okay, so there's software around to access our data and metadata. And some of them are standards-based, the blue ones. They are like they evolved from a standard. And then you support a lot of data providers, both in the PX world and the SDMX world. And some of them are lonely guys in this matrix. They support one data source, but they happen to be very specific for this data source. They might add all kind of features that are not in the standard. So there is a use case for them. And we have another category, like the official statistics aggregator sites. And actually it was mentioned this morning, the IPEM, they have also software around, which gives access to harmonized data, survey data, time space, harmonized. And for the economic data, there's also an example. So this is all around us. And we went one step further, looking into the documentation. What does all this software offer? So we identified a number of features, like hiding the endpoint, hiding the dirty details, getting the catalog, what's there in the data source at all. So for discovery. Search, different kind of queries on the endpoint, local caching is a very important feature in many. Getting the cartographic data with the data is a great advantage for making maps. So that's additional features. Registries have been said so much about it. We scored them in a FAIR matrix, and I think we are strong. It's strong on findability, but not so strong on reusability. And there's coming up this idea about, in future, could we, with this community, create one-for-all software that gives access to all the data? Isn't this our duty? Okay. Official statistics and linked data. So I'm now ending the software perspective. We were also very interested in linked data. And I'm still not sure which way to go. Because I'm a fan of linked data. I'm also kind of a fan of SDMX. I'm a fan of many things, actually. I see the use case of everything. So, and my questions are always, what way to go? What's the best to do? So let's look around about the linked data initiative. And I know there are much more than these, but we in the paper, please have a look if you're interested. We said something about the Eurostat activities, but they were already presented for a lot on the left. We have someone been working on a knowledge graph in our organization, in the middle, for about 8 years. And he happened to have modeled all kind of knowledge from experts, statistical experts, within this knowledge graph. Interviews, he grabbed all the data, metadata he could get in the institute. It's actually a very rich source of metadata information. It's now backing up our search engine on the website. So this is something that I didn't know before, but it convinced me about the flexibility of the linked data model and what you can do with it. And one other example I came by is the Scottish linked data vocabularies site. It's completely linked data driven, and there are interesting things to see there from the viewpoint of referenceability and the model. So, looking from a distance to the linked data, as I see it right now here, linked data is about linkability. From an official statistics perspective, we are always, this is our official statistics, please use them, they're good. But linking with communities is something completely different. Within our community, we can talk and do linking among institutes, like Eurostat, we link to Eurostat, you see it on this thing. Outside of the official statistics community, we can link to communities like Wikidata. And this is exactly what my linked data expert did. Another thing he did was to model changes in metadata. There's actually an example here. This is maybe too deep to go in. But linked data, the third bullet here, the Dutch linked data shows modeling complex statistical metadata dependencies. So what he did was a complete historical graph of the Dutch geo changes on municipality level for over 2 centuries. And in the Netherlands, we change the municipalities every year, actually. So you have to know that. So last bullet, I don't know about you, but could the current AI data training hunger, because we are all scraped to the max for data and text. Could linked data be picked up more easily than specific statistics standards? That would be a question. Okay. I mentioned FDOs, which is FAIR Digital Objects. And that's a way to, I don't know, harmonize a lot of standards into some higher level principles. It builds on the FAIR principles, of course. Up to now, I talked about the official statistical landscape. And we use a lot of standards. And we have this layered architecture, high-level content, news, charts, thematics, the metadata registries, the estimates in the statistical database. And we have a restricted area, and this is becoming more important for all our organizations, the microdata that we offer to the scientific community. That's a growing business. And we use different standards. And it was already in the earlier talks about using different ways of referenceability. And if you look at the FAIR principle AI, so using a standardized communication protocol, we use different protocols. Well, in this FDO concept, I think there are two things might be interesting for us. It's kind of PID system, identification system for all your artifacts. Should we think about something that works for all layers, for all types of metadata? I'm dreaming here, I know, but okay, that's... And there's this concept of machine actionability. So there are 3 levels. Machine readable, you can read it by a machine. Machine, I forgot, understandable, good metadata. So a machine actionable, we say what you can do with it. And when I heard about that, and combine it with the software layer I was just describing, I think all the software that the community creates on our official statistics makes it actionable. Just a thought, because I'm at the end, so you can read about all the bullets and you can read the paper. If you're interested, please mail me, whatever, all the feedback, welcome. But my conclusion was, to be more fair, there's work to do on all the perspectives. We are not ready yet at all. And only then we can continue our role of trusted data partner in a future data. I'm going to read it now because I have one minute to go even. So that was my statement. I hope you enjoy, and questions and very much also welcome. And if you want to work with us on this awesome list of official statistics, please like it on GitHub and have a look. Thank you.
Thank you very much, Olav. Awesome. So because we're going to have questions at the end, I would ask, please think of the questions that you have for Olav and note them down so that there's not a sort of a last speaker bias in terms of the questions that are asked, and we'll have that discussion later. So I'll take the opportunity to introduce the next speaker, Anikó. Yes. Just while Frank is changing the presentation. Anikó Mohay works at the metadata department of the Hungarian Central Statistical Office. She graduated from the university with a degree in Library and Information Science and has been working in data management researcher at the Statistical Office since 2022. The goal is to achieve methodological improvement in the fields of data and metadata management standards, open data and linked open data solutions with semantic web and ontologies and data storage technologies. And Anikó will speak to us about modernization of the central meta-information system in accordance with link open data and FAIR principles. So more on the FAIR principles. The floor is yours, Anikó.
Thank you so much, and hi everyone. Thank you for the opportunity. I made this presentation with Zsuzsanna Mar. No, I can't. Step. Sorry. Yes, okay. Okay, I skipped the outline because time is short. The Central Meta-Information System is one of the case system, the office, where we record and collect our metadata. What kind of metadata these structure?
You need to lean closer to the mic.
Yeah. Okay, sorry. Oh, yes. Sorry. So what can... No. Okay. It's good? Yeah. So what kind of metadata can we collect and record in our central meta-information system? Structural and descriptive metadata and control metadata. Who are the users, non-expert users and external, and we have two big groups, and external users and internal users. Non-expert users, they require simple and concise, easily understandable description. Definition should be in natural language and readily accessible. Expert users, they need a high quality, clear, precisely formulated metadata. Internal users, statisticians need descriptive and structural metadata. IT expert, statistical data production primary require structural and directive metadata to metadata-driven design database and processes. Examples include the description of production database or data warehouse. Software and programs rely on control metadata for input, requiring directive information this purpose. You can see in this image how we categorization of metadata, users and types based on the metadata. Structural metadata are variables and code lists. Descriptive metadata are contents. Control metadata is a code list. The goal of the metadata system is to have all necessary metadata for the data production process described, stored, and maintained one place within the office. The system operates on database basis, where the structure of database table is also described in metadata. Central meta-information system covers the stages of statistical data production, supported by metadata-driven tools. IT tools, the central meta-information system connected to several other systems where additional stages of GSBPM are implemented. In the system, metadata control actually implemented with the aforementioned control metadata. The application system operates a three-tier environment: developer, testing, and production. The application development takes place Windows-based environment. The foundation of central meta-information system is Oracle SQL developer, user interface SQL form. I would like to say a few words about the principles. We want to follow developing the central meta-information system. We aim to implement the principle linked open data, meaning to publish RDF using semantic technology, thereby facilitating discoverability, accessibility, interoperability, and reusability of our data and metadata. The office deciding whether to upgrade our central meta-information system or purchase a new one. We examine the strengths and weaknesses of the system and identify the task for the development. I showed you what is missing, but time is short. I will talk about this later with the solution. Following, I will present how we plan create, provide, store, and manage metadata within the load architecture according to FAIR principles in the system. The current structure may provide good basic for this implementation. First, we examine the weaknesses of the system and the website based of various criteria you will see in the tables, and we determine the task. First, we examine the possibility of interpreting metadata within the metadata system and on the website. In the central meta-information system, numerous metadata can be recorded for our data. Unfortunately, however, responsible parties often fill out the fields for individual entities incompletely. We would like to change this by specifying more mandatory fields. Before implementing the load architecture, we plan to clean and deduplicate the database. We will query and supplement missing data for each entity type before setting mandatory fields. We aim to formalize various entity types and strive for the use of singular form. It's very important to handle the homonyms and synonyms in the system and assign the relationship them. Our long-term goal would be to create thesaurus, ensuring unified terminology. We publish metadata on the website. However, the site is outdated, does not utilize Web 2.0 technology, and not user-friendly. Load is essentially semantic technology that makes the web content understandable for machines. Furthermore, the RDFs, we have opportunity to link the data visualization to display of individual entities, making our data understandable for users. Additional graph visualization makes the relationship between data discoverable. The next investigation was how could link the metadata. Currently, what the relationship we can define between them. Data and metadata converted into different formats. International dictionaries and ontologies are not used. It is important that our data and metadata be available in standardized format on both on the website and in the system. To achieve this is necessary to develop a converter that transforms the generated data and metadata into appropriate format. The essence of the semantic web is the idea that suggests making data stored in the internet, not only a text characters, but also way the machine can understand. The semantic web essentially the realization of load. Currently, the machine readability of metadata is missing. In the next section, I provide solution for this. In the central meta-information systems, there are numerous opportunities to link metadata describing individual entity types. Within those entities, concept can be linked with code list, variables, regulation, although this does not always occur. For example, concept could be used defining variables, and code list as well enabled by function of the central meta-information system. We also examined how accessible and discoverable the metadata are on the website and in the system. In the central meta-information system, individual modules provide the interface for recording the most important metadata. However, this input interface is outdated, it's not user-friendly, the function buttons not work properly, the interface is not responsive, and the subsystem cannot be used concurrently. Improving this currently in progress. Metadata on the website not easily found. Currently, it's difficult to find the most important entities published on the website. And search engines cannot find the website either. It's necessary to use search engine optimization tools. To achieve this, the following tools should be used. HTML improvements use the schema.org dictionary, keyword optimization, and linking to external reference. This is also a form of semantic publishing. The schema.org dictionary can be used to describe our data, and this can be placed the source code of the website and in JSON-LD format. The metadata can be downloaded from central meta-information system available in Excel or HTML tables. However, on the website, only selected classification elements are available for download. Unfortunately, there is no option to download the data various exchange formats. One form of semantic publication to make RDFs available as downloadable files on the website. In the central meta-information system, entities have validity periods, and various versions are stored in the Oracle database. An essential step in search engine optimization to link external reference our data, such as Wikipedia and Wikidata links, which not only support ranking but also direct users to additional relevant content. This step greatly contributes to contextualizing our data and aiding interpretation. If many people also refer to our websites, it helps with ranking and builds trust on our website, ensuring the users receive reliable content. In the central meta-information system and database, the functionality to link to individual entities is currently only available in the concept model you can see in the screen. Next image, we can see how we can generate RDF from relational database. Finally, examine the cost of producing metadata. The current cost of metadata production is high because metadata reuse across different domains does not always occur. By implementing linked open data architecture using URI, making data accessible, and defining relationship between different versions, we support data reuse and operate most cost effectively. Disadvantage is decentralized operation and many users creating metadata control is not resolved through IT means. The FAIR principles also articulate the principle of rich metadata description. It is usefulness, the describing our data with metadata time-consuming tests, but it greatly improves the quality of our data. In the central meta-information system, we have the opportunity to link our data and describe them with various entity types. Few words about development. What is a rule? Development should be done within a project team comprising diverse experts. Supervision of operations should be centralized. Training and consultancy should be provided to stakeholders. Efforts should be made to promote the use of metadata. Semantic web technology has slower conquering world than we hoped 20 years ago. The problem lies in the quality of published dataset, the scarcity of experts, and weak technology support. It's crucial when publish our metadata according to linked open data principles and use existing dictionary when publishing or at least align our metadata with these dictionaries. If the office decides to develop the current system and utilize load technology, the development should include connecting data sources to concept, linking concept to each other, linking code lists to concepts, and so on. Furthermore, the implement the FAIR principles is necessary create a code list for Creative Commons values and address connection with external registries using interface. Biggest challenge for both semantic technology and office is ensuring compliance with artificial intelligence developments. It can be beneficial for both external and internal users to create, for example, chatbot for interprets RDF triplets that also use verified international dictionaries and can provide data context with quality attributes. Okay. Thank you so much.
Thank you very much, Anikó, and thank you very much also for sticking to time. So there's a lot of information there. So please think about your questions for Anikó about when we come to the discussion. Our next speaker is Konstantin Laikam, who is chair of the Interstate Statistical Committee of the Commonwealth of Independent States, CIS Stat. He has a doctorate in economics and a doctorate in IT, 2 doctors. He led the development of statistical methodology and information systems for statistics, and currently is leading the development of a data hub on statistical data and metadata in the CIS. And he will talk to, so this, that we started off the session, I should have said this, with 2 long papers, and now we have two shorter papers. So Konstantin will have 10 minutes, and he'll talk to us about FAIR statistics, semantically rich development for linked open statistical data creation and interpretation. The floor is yours.
Yeah. Thank you very much for my presentation. Dear colleagues, the Stat Committee of CIS, CIS is Commonwealth of Independent States, is an international statistical organization. Almost its main function, it is important to highlight, first, the collection of data from national statistical services of CIS countries. Second, summarizing data for the Commonwealth. And third, the publication of statistical data and metadata for the countries and for the CIS in general. Therefore, the issues of statistical terminology and methodology, harmonization, comparability of statistical data across countries, and accordingly formation and dissemination of high-quality metadata is very relevant for our organization. SDMX is commonly used for metadata dissemination. However, the analysis of its implementation shows that there are still some challenges. First, SDMX object model doesn't support the entire variety of relationships between metadata entities. Extended metadata ESMS is optional, quite complex to complete, and therefore often not used at all. Brief metadata, DSD, describes only the structure and encoding the data of data sets. Third, metadata is usually distributed separately from data. Do you know it? The implementation of lot principles proposed by the UNC high-level group on the modernization of official Statistique would address these challenges. Loss data hubs, commonly based on RDF data cube vocabulary, combine the benefits of SDMX and linked data. Our experience in creating semantic models in statistics proves that the success of this work is crucially influenced by the quality of methodology description, focused above all on terminology, as well as on the richness of semantic connections. Poor semantics of the basic models ensures the compliance with the standards, but does not realize all the potential of semantic web and doesn't not guarantee an ambiguous machine interpretation and clear human understanding of data. Considering the international and our own experience, CSStat realized the idea of building a semantically rich interpretation environment with the aim to improve the quality of statistical data and metadata, to harmonize statistical terminology and align methodology, to comply with FAIR principles, to provide semantic interoperability and reuse, and facilitate metadata relevant interpretation. Due to this approach, we've got the following benefits. Developed semantic models and statistics, generated smart metadata, semantically rich lot sets, expert validation of results using visualization tools. To achieve these goals and benefits, we focused on the following objectives listed on this slide. To form the methodological and terminological basis for constructing smart metadata and preparing lost in our data hub, to provide collaboration tools for experts, statisticians, and IT specialized, supporting harmonization of statistical terminology and alignment of classifications, to implement the technology for describing statistical indicators, to generate smart metadata based on this description and semantically enrich of corresponding lot sets, to ensure the cataloging and dissemination lots set and semantic assessed such as core vocabulary, glossaries, controlled vocabularies, and to support the consistently validation of developing smart metadata and lot sets and semantically rich interpretation environment. To meet these objectives, two systems have been specially created in our data hub. They are the semantic knowledge management system and a system for lost preparation and dissemination. Those two systems provide a single, consistent terminological and methodological framework for the development of rich semantic models used for lost and smart metadata. It's open for external customs and integrated with our data warehouse and our business intelligence analytical system. This slide represents the general logic of this system's operation cycle, as well as the main platform, standards, and tools used for the realization. Labor statistic is the first domain used for this system's evaluation. Its digital library already consists of more than 80 documents, methodological documents. Half of them are structured and published on XWiki pages using hypertext markup, linking glossary terms and related documents. It should be noticed that for the first time in CIS countries, 32 lot sets were developed and equipped with smart metadata available for 10 statistical indicators. By the end of the year, we are planning to add 7 more domains. So, as a result of this work, an environmental of meaningful interpretation of smart metadata and loss has been created and provided to the customers. The developed data and metadata meet FAIR principles as detailed in this table. It confirms the feasibility